So we've spent a lot of time writing linear equations, and what we're going to do here is we're going to write a linear equation, and then we're going to actually use that linear equation to make a prediction, which is one of the things that linear equations are really useful for. So this problem says the graph shows the cost for taxi rides of different distances. Predict the cost of a taxi ride that covers a distance of 6.5 miles. So let's zoom in and take a look at the graph to start off with. We've got our distance on the x-axis and the cost of the ride on the y-axis. And it looks like this graph is made up of 4 points that have been connected to show the linear relationship. So here's one of the points right here. And that distance looks like it's 2 miles because on the x-axis, each one of these lines is worth 2. It's going by 2. So this is 2, 4, 6, 8, 10. So it looks like that one's 2 miles. Then we've got a point right here at 4 miles. So that's the cost of a 4-mile trip. This is a 6-mile trip, and this is an 8-mile trip. The problem is asking us to predict the cost of a 6.5-mile trip. So 6.5 would be about right here. So I think this is a reasonable estimate for where 6.5 miles would be. It looks like it's maybe $16 or perhaps slightly above $16. So we're expecting our answer to be about 16-ish dollars. So it's always a good idea when you have a prediction problem before you start really doing any math to get an idea of what I think a reasonable answer would be. So I'm expecting a reasonable answer to this problem to be about $16. Sometimes whenever you start doing the math, it's easy to make a little mistake and get an answer that's way, way off. Like if I start doing this and I get an answer that's a negative number, for example, or if I get an answer that's like $100, I want to always be able to keep in the back of my mind, I know if I get an answer like that, I have made a math error somewhere because my answer should be about $16. Even if I get an answer that's $20, I know I've made a mistake somewhere because even an 8-mile ride is less than $20. So 6.5 should be less than 20. So I can even get a shorter range than it should be less than 100 or not negative by saying, well, a 6-mile ride is under $16 and an 8-mile ride is under 20. So my answer is probably going to be between 14 and $20. So if I get an answer that's below $14 or above $20, I know I've messed up somewhere. Okay, so before I even start doing math, I know if it's below 14 or above 20, I've made a math error and my answer should be around $16. Okay, so if I get something that's not in that range, I know I've messed up. Okay, here we go. I need to predict the cost of this taxi ride, and in order to do that, I need a linear equation. Well, like every linear equation we've done this entire semester, we're going to be looking for slope-intercept form, meaning we need the slope and the y-intercept. And in order to solve this problem, we need 2 points. So we can use any 2 points that are here on the graph, any 2 that we like. I think if we can use any points, we should use the 2 that are easiest. None of these are exactly on the intersection, unfortunately, but I think this point right here is a good one to use. That point looks like it's 2, 7. And the reason I think it's safe to say this one is 2, 7 is because the x and the y-axis are both going by 2's. And this is right in the middle, in between 6 and 8. So I think it's reasonable to say that this point is 2, 7. And then the next point that I want to use is the very next point, because it's the next lowest numbers. That is a distance of 4 miles. So the point is 4, and then this is right in between 10 and 12. So I'm going to say 4, 11. So the 2 points that I'm going to use are 2, 7 and 4, 11. Seems reasonable. Okay, so let's use those 2 points, 2, 7 and 4, 11. And I'm starting off with those 2 points because the first thing that we're going to do is find slope. Slope is found by getting our change in y over the change in x So we're going to subtract our two y coordinates. Our two y coordinates are 7 and 11. So to figure out what that changes by, we'll do 11 minus 7, which is 4. And then we'll do our change in x on the bottom. Our x's are 2 and 4, so we'll do 4 minus 2 to find our change in x, and that is 2. So our slope is 2. Great. Now we've got slope, we need our y-intercept. It sure looks from the graph like our y-intercept is going to be 3. Totally reasonable for us to say that the y-intercept is going to be 3, but we can figure it out for sure without making a guess. And so if we can figure it out for sure, let's go ahead and do it. We'll do y equals mx plus b. We know that our m is going to be 2. Right there, m equals 2. So we need an x and a y to substitute. Again, let's just use the smallest one we can find. Let's use 2, 7 for our x and y. Let's replace the x with 2, and let's do the y with 7. I'm going to use different colors for the x and y so that it's easy to tell which is which. I'm going to do x in blue and y in red. Okay, so y equals is going to be 7 equals. Let's replace the m with 2. And instead of 2 times x, we're going to do 2 times 2 because we're going to replace that x with 2 plus b. And now we'll multiply the 2's. 2 times 2 is 4. So we have 7. Oops, probably don't need the ruler. 7 equals 2 times 2 is 4 plus b. And 4 plus what is 7? B is obviously going to be 3. We can verify this by subtracting 4 on both sides using the subtraction property of equality. B equals 3. So our equation in slope-intercept form is y equals 2x plus 3. The 2 for the slope means that we are being charged, looks like $2 per mile. And the y-intercept of 3 means there is a $3, as we'll just call it a surcharge, or like a $3 base fee just to get in the cab in the first place per ride. Okay, that's what those numbers mean. $3 to get in the cab and then $2 per mile. Now the question was, what's the cost of a ride that covers 6.5 miles? We can see from the graph that miles was our x value. We've been measuring miles in x. So what the question is asking is, what is the value of y? So find y, the cost, when x, the miles, equals 6.5. So all we're going to do is take our equation, y equals 2x plus 3, and replace that x with 6.5. So this is just multiplication and addition. Y equals 2 times 6.5 is 13. And 13 plus 3 is 16. So it would cost $16 for a 6.5 mile ride. Now remember, way back at the beginning, before we even started doing any math, we said, let's think about what a reasonable answer would be. Let's go see, does our answer make sense? We said we expected the answer to be about $16, and that if it was below 14 or above 20, we knew we had messed up. Well, our answer actually was $16. So our answer definitely makes sense with what we predicted it would be. So that makes me feel confident that we did this correctly.